The Earth hangs suspended, a blue and green jewel against the vast backdrop of space, but this serene image is broken by the glint of metal, the cold, hard lines of satellites orbiting silently above. These are the silent sentinels of a new kind of war, fought with data and algorithms. Drones, sleek and deadly, cut through the air, relaying every image back to control centers. This is the new face of conflict, where the battlefield is as boundless as the sky itself. Gone are the days of brute force, of overwhelming numbers. The new battlefield is defined by speed, by the ability to adapt and evolve faster than the enemy. Victory no longer goes to the strongest, but to the smartest, to those who can harness the power of technology to gain an insurmountable edge. This is the age of artificial intelligence, of machine learning, of algorithms that can sift through mountains of data, identify patterns invisible to the human eye, and predict the enemy's next move before they even conceive it. This is not science fiction. This is the reality of modern warfare. The modern battlefield is an overwhelming sensory experience, a chaotic symphony of light, sound, and motion. For the soldier on the ground, every decision, every twitch of the finger on the trigger can mean the difference between life and death. But in this maelstrom of information, how does one separate the vital from the irrelevant, the signal from the noise? The answer lies not in human intuition alone, but in the transformative power of retrieval-augmented generation, or RAG.
Imagine for a moment a soldier on patrol, navigating the rubble-strewn streets of a once thriving city, now scarred by conflict. Every shattered window, every shadowed doorway could conceal a threat. But this soldier is not alone. He is equipped with a helmet that projects a constant stream of data onto his visor, transforming his perception of the battlefield.
The soldier spots movement in a building across the street. Instinct tells him to take cover, to treat it as a potential threat. But his RAG system goes further, analyzing the movement, comparing it to known enemy tactics, even factoring in the time of day, the weather conditions, and the structural integrity of the building itself.
Within milliseconds, the soldier's visor displays a series of probabilities. The likelihood that the movement is hostile, the potential types of weapons that might be present, even the most strategically advantageous routes for the soldier to take, whether advancing or retreating. This is not about replacing human judgment. It's about augmenting it, providing the soldier with the information he needs to make the most informed decision possible.
The integration of RAG into military operations is not about replacing human soldiers with machines. It's about creating a powerful synergy between human intuition and artificial intelligence.
The soldier on the ground, with his years of training, his instincts honed by experience, remains an essential element of this new era of warfare.
But now, he is no longer alone in the heat of battle. He has a partner, a silent, ever-vigilant companion that can process information at speeds no human can match, providing him with the insights he needs to make the right call at the right time, every time. The battlefield is a realm of constant flux, a chaotic dance of variables, where the unexpected is the rule, not the exception. Traditional military doctrine, with its emphasis on rigid plans and predictable outcomes, struggles to keep pace with this fluidity.
But a new breed of military strategists is emerging, one that embraces uncertainty, not as an obstacle, but as an inherent element of conflict.
This shift in thinking is driven by probabilistic reasoning, a branch of artificial intelligence that allows us to grapple with the inherent unpredictability of the world.
No longer content with seeking certainty where none exists, probabilistic reasoning empowers us to ask not what will happen, but rather what is likely to happen, and with what degree of confidence.
The true power of probabilistic reasoning lies not just in its ability to assess current conditions, but to wargame the future, to explore a multitude of potential outcomes, each with its own set of probabilities.
This allows military planners to move beyond linear, deterministic thinking, to anticipate a wider range of possibilities. and to develop more flexible and adaptable strategies.
Imagine, for instance, a scenario where an Allied convoy must navigate a hostile territory. Traditional planning might focus on identifying the most direct route, securing it with overwhelming force.
But probabilistic reasoning allows us to go further, to model a range of potential threats, from roadside ambushes to enemy air superiority, and to assess the likelihood of each, along with its potential impact on the mission. But probabilistic reasoning, for all its power, is not a crystal ball. It cannot predict the future with absolute certainty, nor can it replace the judgment of experienced military commanders. The human element, with its intuition, its capacity for strategic thinking, and its understanding of the nuances of human behavior, remains an indispensable component of warfare. The challenge, then, is not to choose between human and machine, but to find the optimal balance between the two, to create a system where each complements the strengths of the other. Probabilistic reasoning can provide the raw data, the probabilistic assessments, the war-gamed scenarios, but it is ultimately up to human commanders to weigh these factors, to consider the intangible elements of morale, of political considerations, of the human cost of war, and to make the final decision.
For decades, computing power has followed Moore's law, doubling every couple of years. But now a new paradigm emerges: quantum computing, a leap from binary to the quantum realm.
Imagine a computer operating on qubits, existing in multiple states simultaneously, harnessing superposition and entanglement to solve complex problems.
Cryptography, the art of secret communication, has always been a cat-and-mouse game, a constant struggle between code makers and code breakers. For centuries, the balance of power has shifted back and forth as new encryption methods emerge, only to be countered by ever more sophisticated decryption techniques. But quantum computing threatens to upend this delicate balance, to crack the codes that underpin our digital world.
Many of the encryption algorithms we rely on today, from securing financial transactions to protecting classified military communications, are based on mathematical problems that are computationally difficult for classical computers to solve, but relatively easy for quantum computers. This means that in a world with powerful quantum computers, much of our sensitive data could be vulnerable to attack. Beyond the immediate impact on cryptography, quantum computing promises to reshape the battlefield in ways we are only beginning to imagine. The ability to process vast amounts of data at lightning speed, to sift through the noise and extract actionable intelligence, could give commanders an unprecedented level of situational awareness, allowing them to make decisions with greater speed and precision than ever before.
Imagine a drone swarm, thousands of autonomous aircraft operating in concert, their movements coordinated by a quantum computer capable of analyzing the complex dynamics of the battlefield in real time, adapting their formations and tactics on the fly to counter emerging threats. Or picture a logistics network spanning continents, optimized by a quantum algorithm that can calculate the most efficient routes for troop movements, supply deliveries, and casualty evacuations, even in the face of constantly changing conditions.
The marriage of military might and cutting-edge technology has always been a dance with ethical dilemmas. Each leap in destructive power forces humanity to confront uncomfortable questions about war and acceptable conduct. AI and quantum technologies in the military present new ethical complexities, challenging our assumptions about morality and responsibility.
At the heart of this dilemma lies the question of algorithmic conscience. Can a machine truly understand the moral weight of its actions?
The allure of autonomous weapons systems, drones that can select and engage targets without human intervention, algorithms that can launch counterstrikes faster than any human operator, is undeniable. In the heat of battle, where milliseconds can mean the difference between victory and defeat, the temptation to cede control to machines, to unleash the full potential of AI and quantum computing, will be immense.
But this seductive efficiency comes at a price: the erosion of human control over the use of lethal force. If we allow machines to make life or death decisions on the battlefield, who bears the responsibility when things go wrong? Who is accountable for collateral damage, for unintended consequences, for the potential for algorithms to escalate conflicts in ways that human commanders never intended? Towards a new Geneva Convention international law in the quantum age.
The existing framework of international law, forged in the crucible of 20th century conflicts, is struggling to keep pace with the rapid evolution of military technology. The Geneva Conventions, with their emphasis on proportionality, distinction, and the avoidance of unnecessary suffering, were drafted in a world before AI, before quantum computing, before the very concept of autonomous warfare was even imaginable.
How do we apply these principles to algorithms that can make life or death decisions in milliseconds? How do we ensure that the use of AI and quantum technologies in war adheres to the principles of humanity and the dictates of a just war? These are not merely academic questions. They are urgent challenges that demand a global response. The shifting sands of warfare. Future battlefields will differ greatly from historical ones. Gone will be massed armies clashing across open plains, replaced by conflicts of speed, precision, and AI. Wars fought with algorithms and quantum particles. Drone swarms guided by quantum computers dominate the sky. Autonomous vehicles prowl ghost cities, sensors alert. Strategic advantage in the age of intelligent machines. In this new era of warfare, strategic advantage will hinge on mastering the interplay of human intuition and artificial intelligence. The ability to leverage the speed and computational power of quantum computers while retaining human oversight and ethical judgment will be paramount. Imagine a command center where human commanders, augmented by advanced neural interfaces, work side by side with AI systems. Holographic projections shimmer around them, displaying a constantly evolving tapestry of data, enemy troop movements, terrain analysis, probabilistic forecasts of potential outcomes. Maintaining equilibrium, a world redefined. The implications of this technological revolution extend far beyond the battlefield. As AI and quantum computing reshape the nature of warfare, they will also reshape the very fabric of international relations, redefining the balance of power and challenging the established order. Nations that lag behind in this technological arms race risk becoming increasingly vulnerable, their conventional forces outmatched by adversaries wielding the power of intelligent machines. The potential for a widening technological divide, with a handful of powerful nations holding a decisive advantage over the rest, is a sobering prospect. The race to harness the power of retrieval augmented generation, probabilistic reasoning, and quantum computing is a global endeavor, reshaping alliances and fueling rivalries. From the bustling megacities of Asia to the high-tech corridors of North America and Europe, the pursuit of intelligent machines is driven by ambition and fear. This is about developing the capacity to process information faster and to outmaneuver adversaries in the cognitive domain. While the pursuit of technological superiority in AI is often characterized by fierce competition, there is also a growing recognition that these challenges cannot be addressed by any one nation alone. The potential for unintended consequences and for the escalation of conflicts beyond human control demands international cooperation and dialogue. We stand at the cusp of a new era in military history, one where the battlefields of tomorrow will be shaped not only by the raw power of weapons, but by the lightning-fast calculations of algorithms and the mind-bending capabilities of quantum computers. The convergence of these transformative technologies is a profound paradigm shift. Retrieval augmented generation delivers actionable intelligence, transforming situational awareness. The battlefield of the future will be transparent, every movement laid bare before intelligent machines. This technological revolution brings challenges, ethical dilemmas, and potential unintended consequences. We must proceed with caution and wisdom, understanding the profound responsibility of wielding transformative power. A nation's strength lies in its commitment to using technology responsibly and ethically. The future of defense is in cultivating smarter minds and educating a new generation fluent in AI. Leaders must embrace technology as a powerful ally in the pursuit of peace and security, always seeking to harness transformative technologies for the betterment of humanity.